In the last video, I challenged you to write multiple Fibonacci functions, ones that could calculate the nth term of the Fibonacci sequence either iteratively or recursively. And I'll do the first shot right over here. And I'll show you over the next few videos that there's really multiple ways of even doing this just iteratively. So let's define our function Fibonacci, and it has a parameter n. So that's what that is what we are going to pass to the function. And we know that by definition, the first two terms of the Fibonacci sequence are 0 and 1. So let's make a list for ourselves. And so this is interesting. So this is the first time we're really going to do some actual list manipulation in this video. So the terms here, the 0th term of the Fibonacci sequence is 0, and the first one is 1. This is by definition. So we're just gonna kind of hard code that in right there. And then what we're going to do is if we're then going to construct this list to all of the terms up to and including the nth term, and then return the nth term from that list. And the reason why I'm going to do it this way is it's able to save up kind of a memory of all of the Fibonacci numbers, which is helpful for computing each incremental Fibonacci number. So let's do it this way. I'm going to use a while loop. You could do it using a for loop, but for me, a while loop feels a little bit more natural for this. And actually, before I even define the while loop, I'm going to set my variable of iteration, I should say. I'm going to set that equal to 0. And you're going to see how this works in a second. So I'm going to say while I is less than or equal to n. So I is going to start at 0 and then go up to n. And actually, frankly, I shouldn't start at 0, because we already have the 0th term here and the first term here. And we want to construct the second, third, fourth, all the way to the nth term. So actually, let's start I at 2. So we already have the 0th term in the first term. We then want to construct the second term. So that's why we're going to start I equals 2, all the way up to and including the nth term. So that's why we say less than or equal to n. We're going to keep adding terms to this sequence. So while I is less than or equal to n, I'm going to take this list right here, and to the end of that list, and this is a built-in function for any list in Python, and you're learning it now, and you could look it up, and actually my IDE tells me how to use it. I can add to the end of that list another term. And that next term I'm going to add to the end of the list is going to be the sum of the previous two terms. So it's going to be terms I minus 1. So that's the previous term. Terms I minus 1 literally refers to the previous term. I minus 1 plus terms I minus 2. So it's essentially going to construct this Fibonacci sequence and build it in this list. And then we're going to increment I. I is equal to I plus 1. If we never increment I, then this loop will just keep going on forever and ever. But this way, it's going to keep going up and up and up until at some point I is not going to be less than or equal to n, and then we're going to break out of the loop. And then when we break out of the loop, let me do it right over it. When we break out of the loop, we can then return the nth Fibonacci term in the sequence. So we're going to return we're going to return the nth term in terms. So let's see if this works. Let's see, does this make sense? So I'm going to go all the way up to the nth term, And actually, the nth term here, yes, this should work. Because if this was Fibonacci of 0, I want to return terms of 0, which is this term right here. If it's Fibonacci of 1, I want to return this term right over here. So it's the first term in terms right here, not the 0th, but the first. So this feels like it should work. And actually, even before I run it, I want you to make sure you understand what I've done here with the list. So I'm going to show you a little bit of example of how these lists work. So if I define a list as, I don't know, 1, 1, 2. That's my list. And if I then say, oh, it's doing something weird. So I'm going to define my list as 1, 2. So if I type A, it's 1, 2. If I append to A dot append. So if I append let's say I append a 7 to it. Then if I look at A, I have a 7 at the end of it. If I want to refer to the elements here, A of 0 should be the first element. A the second element, I just put the 2 in the brackets, and it should give me the 7. So that's exactly what I'm doing over here. I'm saying terms of I minus 1. So we're going to add a new term over here. So this first time we go through the loop, we're going to add a new term, and it's going to be the sum of terms of I minus 1. So in that first loop, I is 2, I minus 1 is 1. So terms of 1 plus terms of 0. So it's going to be terms of 1, which is 1, plus terms of 0. And then it keeps doing that all the way until we construct the nth term. Well, enough talk, and I'll step through it a little bit clearer in the next video with a particular example. But let's just see if what we wrote actually works. So let me run it. All right, and let's see if we get the proper results. Fibonacci. Well, let's just start from the beginning. Fibonacci of 0. Well, that looks good. Let's try Fibonacci of 1. That looks good. Fibonacci of 2, this should also be 1. That looks good. Fibonacci of 3, this should be 2 now, because we're taking the sum of 1 plus 1. That works. Let's try the Fibonacci of 10. Yeah, that looks pretty good. Let's try the Fibonacci of something huge. Fibonacci of 100. Well, this gets a little bit. I won't go into well, this is a very large number, and I'm not going to go into the whole floating, kind of the long numbers and the super large ones. But let's try something a little bit smaller here. So let's try Fibonacci of 20. So it looks like it works, and you can verify it for yourself. So this is just one implementation of it. In the next few videos, I'm going to try another way to implement it. Maybe I'll do it with a for loop, or we can also do it recursively.